Okay, I'm back to cover a few of the WebAssembly topics that I don't know where the word topics came from there, that I missed before. Um, so uh, just stay with me while I go over those. Um, so firstly, there was the thing of compiling, and I said well, I didn't know how to do it anymore, and I hadn't put it in the README. And it absolutely appears that I had not put it in the README. In fact, I think for WASM, um, yeah. If I'd put it in there, I know I would have included that because that is the tool that I had been using. So if we go back to Safari, um, this is where I started from way back when I started looking at the WebAssembly stuff. Um, Obviously, the text format thing here on Mozilla.org, but it's fairly nice and explanatory. But this is the key thing here. So you can use a tool called wa.2 to compile it, and it's a very simple command. It's just the command followed by the source file and then -o and the destination file, which is the same as any common compiler that you would normally encounter. So this is the GitHub for it. I'm mostly just showing you this because so that you can have a look at what specifically the path is, just for later reference. But I've already got a copy of it checked out. Yes, it's over here. Fantastic. So I'm going to show you. I'm going to show you what you do with that. Although it's extremely simple. I'm just making sure first of all that I don't have nonsense in there, which I do not. So all you do is if you have the developer tools installed, obviously I'm on a Mac, so it's the Mac developer tools, and you need to install the command line versions. You just run make. That's it. And in a second, it's going to start. Yes, going through 1%, 2%. It's a very long process, so I will come back to that in a little minute. While it's doing that, I'm going to go over to the WebAssembly homepage, which is webassembly.org, and I'm going to show you where the documentation is for the commands that I missed. And I'll do something else while I'm there as well. So go into docs, and instantly I kind of don't know where to find it. No, it wasn't docs, it's spec. You see, I got it wrong the first time, as if by magic. So browser version, obviously. And we're looking at the text format here and instructions. And this is the kind of nightmare that you have to look at. This is actually not as bad as it might appear to you. This is really just definitions on the right, on the left, and how they behave on the right. So if we can go down a little bit, we've got the memory instructions, which were the ones I was confused about. So here's so this is saying, yeah, okay. I'm gonna say off the top of my head, I don't know what plain instro I is, but whatever, it's the command. I'm not too bothered about that. So this is the name of the command and what it takes, which is a memog 1. In fact, actually, I want this one. I want load8u, I believe, and this links to the correct part of the documentation. So it's actually not the relevant part of the documentation about what it does is not in the text format section, which you would kind of expect. It's just a little bit unfriendly to do that. So here I am in the memory instructions section, and here it is. So it takes load and store instructions. They take a memory immediate that contains an address offset, and the expected alignment. For this purpose, I think the expected alignment isn't included. I think you probably couldn't include the alignment, but for this purpose, it's not. And yes, you can optionally specify storage size that's small and bit with the respective type. So in this case, it was saying I want an 8-bit storage size to load from. In other words, I'm loading 8 bits from memory. That's really all there is to it. So I would have to actually dig into it to find out exactly how it works it out. But I believe that it just uses the memory declarations in order, or perhaps there's only one memory declaration. It doesn't matter for my purpose because I am only using one. There can be only one. It's very Highland. So yeah, where we have the loads and the stores, that's all they're doing. They're just operating. Yeah, there you go. That load 8u. They're just operating on an offset. So this is finding something in the memory at a particular offset, and in this case, because it's the last instruction on the list, it'll return it. That's really that's it. That's all those instructions do. And obviously, store is the exact opposite, but you don't. You don't. I think you don't specify size at all with store. In fact, I can just go back over there. Oh, you can specify a size, but I'm not doing that. I'm just doing a single store where I am doing that. So that's all there is to that. While I'm at it, I will give it a try doing the reversing thing. And in fact, I'll show you where that's specified. So going back into text format, if we look at instructions at the very bottom, folded instructions, that's what this business is. And as you can see, it just means that you can call an instruction with the arguments it takes before the instruction, rather than doing the whole thing in brackets and putting it afterwards. So here, I can put this slot just before i32.load8u, and that's valid. And further, I can take these two and put them before i32.add, and that's valid. Or at least it's not complaining at me at the moment. But in general, what you will want to do in most of these situations is just keep them bracketed up anyway, because it will be much clearer to you that is what is going on. Mostly you don't want to be relying on the stack for that purpose. I'm just going to go check and see how my compiling went. It went brilliantly. There you go. Had no problems at all. I did actually have a problem when I was updating for this, because I wanted to make sure that I had updated my WABT, whatever it is, before I ran the compiler, just to make sure I wasn't being a complete idiot and producing output that was of no relevance to anybody at all. And when I did that, I had some out-of-date submodules, and that's a situation that you do come up against sometimes. Mostly people don't use submodules, Git submodules that is, because of these kinds of problems. But basically, when you have submodules that are perhaps not started up, or are perhaps not on the correct version, to start them up, it's git submodule init, which I've already done, so it's not doing anything here. And to get them on the correct version, it's git submodule update. And usually these kind of things, those kind of commands will get you out of trouble. But you can also configure Git for that stuff. Right, so I'm going to show the compiling process. There, that's it. that's all there is to it. You just run the relevant command with the source and the destination, and there's nothing else to it. So it's not it's not difficult. Probably if you are doing this kind of for longer term, you might want to have say a package.json with a rule in there, or just write a quick ad hoc script to take care of it. It's not particularly complicated to do that. And that is it as far as I know. Those are all the things that I missed. I did look up what happens with then that unhelpfully, as I've discovered, Visual Studio Code is being nasty to me here, because look, this is the spec. Here it is. Here's the spec, and it is if blah, 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 then something else something. So what I've got there is actually completely correct, but you can see that it would have also been perfectly fine to just have it without the brackets and then having the contents of the then part just immediately following the result type and then have the else on its own. In fact, I think actually I might have the else expressed incorrectly as far as the requirements are concerned for this, but it doesn't actually matter. It'll still compile just fine. Right, I'm just going to see if there's anything else that that I might have missed from this. I don't think there was. I will say that this is not a terrifically exciting module that I've got here. So you can see that it is doing stuff with memory, and ultimately you do have to do stuff with memory to produce any interesting results, because otherwise it would have to fundamentally be a very simple operation. If you were to operate with strings, for example, you would need to do that by shoving it into memory and then having a function which operates on the relevant part of memory. But in fact, that's not a thing that I'm actually doing. So where it is using the load and store instructions, those are operating on completely binary data here. In fact, this is what this is doing, which might be apparent if you were noticing the specifics of one of the if statements, I think, that I was going over. These are, look at how many times I32 appears. That's ridiculous. These are actually operating on 4-bit values because I only need 4 bits, and I wanted to use the smallest amount of memory possible for this purpose. So it's, yes, binary data. In fact, it is, so strictly speaking, it's numbers in these 4 bits, but each of these numbers represents a direction, as it happens. Those directions are the directions that were shown with the arrows in the previous example. So what this is actually doing is going out in all the directions and then writing the direction back to the origin point, or rather writing the direction back to the previous point, and then when the 2 points connect, there is a simple direction from both sides back to the respective origin points, and that gives me one of the shortest paths, which, as you can see, was reasonably efficient, but it's not it's not fantastic. And you know what? Probably what I will do, depending on how far I'm into this video, I guess I'm not too far. I'm going to go into Safari. Oh no, wait, no. You know what? I'm probably not going to do that now. I'll put it into another video, because I think this kind of deserves to be given its own full topic discussion. But I will go over performance. That's what I was going to talk about. Just briefly, what I will say though is that when you're looking at these things and you have numbers which are in milliseconds, which I'm not going to show right now because I need to do a bit of fiddling around to get to that point. You might look at a number that's say 50 milliseconds and think, wow, that's basically 0 time. That's amazing. I want to do that. But for a lot of situations, you might be doing the same operation but on a much larger data set, or you might be doing the same operation much more frequently, and when you're doing that, 50 milliseconds is a 20th of a second. It's actually quite a large amount if you're going to be doing it, say, 200 times. That's 10 seconds. That's a long time. You'd be sitting there, you'd be bored. So what you actually do, what you do need to care about to some extent is exactly where those milliseconds are spent, whether it's spent doing stuff that you don't actually want to do, and that's why that's why I have this WebAssembly stuff here. I mean, you obviously will have noticed that it took about half the amount of time as the equivalent JavaScript call, which I might as well show to you while I'm here. So this is the equivalent JavaScript source, which is quite a lot shorter. No, thank you. And this is, this isn't inefficient JavaScript. This is completely straightforward. But because of the way that the JavaScript concepts work, it has to, the compiler has to understand a lot about what's going on in order to properly optimize it. And it's difficult for it to have that understanding. So what I can do is, with my knowledge of what's going on, I can essentially pre-compile it into this stuff, which makes a lot more sense. It's a lot easier to deal with. So that's all I'm going to talk about today. So this is going to be a relatively short one. And next time I will come back and talk about performance.